Okay, so this is a video on arcs and chords. So the first thing we want to do is we want to make a circle. So let's do that again. Oops, too small. Let's make a bigger one. There we go. There's our circle. And what I want to do is I'm going to put a point here. We're going to call that the center. And okay, so the first thing we have to establish is what is a central angle. So if I draw from a point on the circle to another point on the circle and I make an angle, this is through the center. This is what we call a central angle. Okay, so let's label some of these points here. We'll call this A, B, and O. Okay, so the portions of a circle, so like this little part of the circle here, this part of the circle is what's called an arc. And this is what's called a minor arc. Okay, so because it's on the interior of the central angle. So this is what is called a minor arc, and the minor arc is AB. Okay. Now if I have a point C over here, I have another arc. So an arc is a portion of the circle, right? So this is the other arc. Okay. So each central angle will form two arcs. And this is what's called a major arc, because it's the one that's not on the interior of the central angle. And we label these with 3 letters. And I can call this one arc A, C, B. Now, these arcs have measures, and these measures relate to the measure of the central angle. So let's say that this is a 95-degree angle. Then the measure of arc AB is 95 degrees. And the measure of arc ACB will be 360 minus 95. So let's see, 360 minus 95. What would that be? 360 minus 95 is 265 degrees. So that is the measure of 265 degrees. That is the measure of the major arc. Now, if I happen to have a circle and it's cut by a diameter, so let's call this A, B, C, and D. You have 2 arcs here. The arc is arc ABC, and the other arc is ADC. So both of these arcs are what are called semicircles, because they are the arcs formed by a diameter. And in that case, both of those arcs will measure 180 degrees. Okay, so that's pretty straightforward about kind of like the relationship between arcs and central angles. Now let's talk, and we got an idea of arc measure here. Now there's a couple of theorems that relate these ideas of arcs and chords. Okay, so we're going to build a circle again. Oops, I need a circle, not an oval. There we go, circle again. Oh, that's an oval. Let's try building a circle. There we go. And we're going to stretch. We're going to talk about how this works with chords. Okay, so first things first. If I have 2 congruent arcs in the circle, so let's say this arc here. Oops, I'm still got the circle thing working. Let's get that off. So this arc here, there we go. And we have maybe an arc over here. That's the same size. So let's say both of these arcs, arc AB and arc CD, both have a measure of X. Okay. Now, if I stretch a chord through those arcs, So let's put a chord there. And a chord through this one. So move that around a little bit. There we go. There's a chord there. So if I stretch a chord through those arcs, then the length of that chord, so the length of segment DC and the length of segment AB will be congruent. So this works both ways. If the chords are congruent, so they have the same measure, then the measure of the arcs will be equal. And if the measure of the arcs is equal, then the measure of the chords is also equal. So that's an if and only if kind of biconditional statement. Okay, so I'm going to clean this up a little bit. I'm going to bring all of this backward and get back to just having my circle. Oh, won't let me do that. All right, so why don't we start new page? Okay, so let's draw another circle here. There we go. And now what we're going to do is we're going to say, okay, if I have a diameter, right? So we're going to go through the center, whoops, and we're going to turn off the circle. And we're going to go through the center. So we're going to make a diameter here. And that is perpendicular to a chord. So I want to build a chord here. So if the diameter is perpendicular to the chord, right, then the diameter bisects the chord, so it breaks it into two equal pieces, and it bisects the arc. So that could be useful. So if I have a diameter and it bisects a chord, it will also, or is perpendicular to the chord, it will also bisect the chord and bisect the arc. Okay, so we've got one more little theorem here about arcs and chords. That's not useful. Let's put it in the middle. There we go. All right, so this time we're going to look at the distance of a chord from the center of the circle. So the easiest way to look at this is to build two chords that are roughly the same length, or that are the same length. They should be. So let's build one there, and one here. Okay, so we're going to say I have two congruent chords, right? And what we're going to say is that if those chords are congruent, let me get my ruler here to make this look a little better. Then the distance from the center to that chord, and this is in the center of the chord there, so these two distances have to be equal. So if this chord and this chord are the same length, then they're both the same distance, and that distance has to be measured over a perpendicular. They have to be the same distance from the center. So that gives us three rules about arcs and chords. One is that equal arcs have equal chords. Two is that if a diameter is perpendicular to a chord, it bisects both the chord and its related arc. And finally, chords that have equal lengths have to be the same distance from the center of the circle.